Hello and welcome. In this video of getting started with Momentum AI, I'll walk you through steps of building and deploying AI and machine learning models. I will show you steps of building AI models with an example of predicting no-shows for doctor's appointments. In the US, on an average of about 30% appointments are missed. These no-shows cost US healthcare system $150 billion yearly. Appropriate action, such as when to do overbooking, can be taken when hospitals and clinics have a way of predicting no-shows. For this exercise, I will use publicly available data for training the AI models. The data is available at this location. In this exercise, I will show you the following 6 steps for building AI model that can predict no-shows for doctor's appointments. These steps are data ingestions to bring the data into the platform, data exploration to understand what the data looks like, data transformation so that we can transform the data in a way that AI needs or AI model needs. We will create training and test sets from the data set that we upload. And then from there, we'll build AI model. That means we will train the model using the training set. Using the test set, we will predict no-shows. In this video, I'll walk you through the steps of all these 6 steps of building the AI models. First, let's understand what the data looks like. So the data is in a CSV format, and this contains this header: patient ID, appointment ID, gender, scheduled date, the date when the patient called to make the appointment, and the appointment day means when the patient has the appointment to see the doctor, patient's age, neighborhood, whether the patient has any scholarship, hypertension, diabetes, alcoholism, handicap, whether the patient has received SMS to inform of the appointment, and then finally the no-show. This is the flag, and this is the variable that we are going to predict. Now we will upload the data into the platform. For that, click Data Management, Upload, create a directory. Let's say no-show CSV data. And here is my data. I drag and drop, upload. Once the data is uploaded, we quickly take a look at the data, and all the data is imported into the platform. We will now ingest the data. Click on Ingest Data. Since this is a CSV file, which is a comma delimited file, we select that and give a name to the data source, browse to the directory where the file is uploaded. This is a comma separated file. Now we'll write a SQL statement to eliminate certain columns. So this SQL statement loads every single field except the neighborhood and scholarship fields, which are not important in predicting the no-show in this case. We run the ingester to ingest the data. So the ingester started running. All right, so ingester finished running. We quickly take a look at the data to make sure that the data is ingested correctly. So the data is in the platform now. Now that data is in the platform, we will create a simple transformation. So for this transformation, we write a simple SQL statement. And what we are doing here is we are bringing all the columns And then we are also extracting the appointment day of the week, whether it's Sunday, Monday, Tuesday, or which day of the week. Also here we are extracting the appointment days after. In other words, when the patient calls and makes the appointment, the day when the patient calls and the day when the appointment is given, what is the duration, or how many days is in advance the patient called to make the appointment. And we also extract the month of the appointment date and day of the month, meaning the date, whether it's a first day of the month or second day of the month, or so and so forth. And then finally we have the appointment day of the month, and then no show. Save this. We'll run this. All right, so it's completed the execution. Now the data is transformed. Let's quickly take a look at the data. All right, so it's data is transformed. We have the appointment day of week, appointment after how many days, and then appointment month, appointment day of month, no show. So it looks like everything processed correctly, and now we have the data transformed in some form. Now that we have data transformed, we will do some level of data exploration. So for that, you click on the transformer and click here, explore data. So here we see that age has a minimum value of -1 and max value 115, which looks like there might be some error in the data. So we'll eliminate those, like -1 age, and we'll try to understand how many of them are, and then we'll remove those records. Also 115 years, although this is possible, but this may be some rare cases, so we'll eliminate that so our model is not skewed. And we also see here that the appointment days after is how many days when the patient called, after how many days the appointment was given. This looks like the appointment was given in the past, which is not possible. So we'll try to eliminate these data as well. So now this is, so three things we identified: the age -1, that we will remove. The appointment after days, the negative values we will remove. And we also notice here that gender, of course, is a character or string. So we'll convert that gender into numbers. And the appointment day of week, which could be name of days such as Sunday, Monday, Tuesday, those are characters. So we'll try to actually convert those characters into numbers. So first, let's try to transform this data again into a form that has cleaner data. That means these values eliminated. Now we'll do a little bit more exploration and try to understand how many of these columns are negative. So appointment days after. So we do a simple SQL statement here, considering this as a table name, and group by appointment days after, and do this as. So there's one record where appointment was made in the past, 2 records. So we'll eliminate these 2 records. So, and then let's try to see whether my data is balanced. So it is very important that for machine learning, especially in classification tasks, we need to see whether my labels or the outcome that I'm going to predict is balanced or not. So let's understand that. So what we will do. So what we see here that no show no has 88,000 record, while yes has 22,000 records. For this exercise, we will remove some of the records that contains no as a no show to balance these numbers. So we'll try to include about 23,000, maybe we'll take 25,000 record that says no as no show, and 22,000 that has yes as yes, no show. So this will look more balanced. For that, we'll need to write another transformer, and the next transformer that I'm going to show is going to be slightly complex in the sense that it will have a multi-step transformation. So let's understand how that transformation works. So we give a name to this transformation. We call it balanced data. And this SQL simply says extract all the records except where the age is a positive number and less than equal to 100, and appointment days is greater than equal to 0. Now this will extract the data and clean the data a little bit, and then we'll apply another level of transformation here. So we click here, add SQL query. Now the next SQL statement here is that we randomly remove some of the records where the no shows is no, and we are taking only 25,000 of those. And then we have taken all of the yeses here. And finally, what we're doing is that we are doing the union of these two. That means yes or no, these two records where the no shows is no and no shows is yes. We're taking these two and doing the union here. The final transformation we will do here is that we take everything from these records, and then we are saying that wherever the no show is no, where the no show is no, mark that as a 0, and wherever the no show is yes, mark that as 1. So now we have all the SQL statements here that transform the data into somewhat cleaner and balanced data. We run the transformation. The transformation is running. Great, so this transformation is completed. Let's look at the data very quickly. All right, so the data looks now cleaner. Let's do another level of exploration so we know everything is correctly transformed. Okay, so now the age is fine. This also looks good. Now we'll see whether our no shows are balanced or not. So reasonably balanced. Now that we have the transform data, we will create a model to convert strings into indices. And there are two such fields, the gender and the day of the week. So we create one model to convert the string into index. And the fields are, so appointment, day of week, and gender. So we'll do here, we'll get the model version number here. Now we define the string to index model, and we'll take the balanced data that is the final transform data, and we create the model. Now the model is running. Great, so model took about 9 seconds. Now we will use this model to predict or to basically convert the string into numbers. Now we give a name, and then these are the features. We will use the model that we just created and the same data set, transform data. So we will convert the string into numbers that will be fed to the machine learning. Now the model has now the indexer has started. Great, the indexer has completed in 8 seconds. So let's look at the data very quickly. And so appointment, day of week, that has been converted into numbers, and we create actually automatically internally a column with the indexed as the basically indicator. Gender is also indexed. Now that we have a cleaner version of data with all the strings converted into numbers, we will create training and test sets. For that, we create transformers, and I'm going to create another transformer. So basically, we are taking the output of this string to index creator that we created, where we have the strings converted into numbers. So we are basically randomly taking 34,000, which is about 70% of the entire data set. And then we are creating the training set. So a very simple transformer. We run this training set, and now while it's running, we'll create the test set. So from the same data set, we are creating about 15,000 rows of test set, which is about 30% of the data. We run the test set. While the test set is running, we can quickly take a look at the training set, make sure everything is correctly processed. All right, so test set is, both the test set and training sets are ready. Great. Now that we have the training set and test set ready, we will now build a machine learning model and use that model to predict no-shows. To create machine learning model, we create new model. And for this training, or for training the model, we are going to use deep learning or artificial neural network multi-layer perceptron classifier. We'll give a name to this, give a model version number, and the feature fields. So we have given the feature fields here and excluded those fields which we think are not important, or some of the string fields that we don't want to include in the model. And the dependent variable in this case is no show. Max number of categories 2, either yes or no. Number of layers. So let's say we build a model with 5 layers and let's say 7 hidden layers. Let's see, we do 100 iteration. Reduce the regularization parameter. And then we will bring our training set here. So we join them together. So now we are feeding this training set data into the model. We run the model. Now the model is running and will take a few seconds to complete. All right, so the training is completed in about 44 seconds. Let's take a look at the model. So these are the feature fields. And here is the summary of the internal evaluation. False positive rate, false positive rate for the label 1, label 0. And then here is our precision for label 0, weighted precision for label 1. Accuracy level is about 65%. So, and then here is the confusion matrix. So now we have the model, and the complete model with the coefficient can be downloaded from here. Now that we have the model ready, we will use this model to do the prediction. For that, create new prediction. No-show prediction using artificial neural network. Let's specify the columns that will be used for predicting the no-shows. And here is the model that we built. And here is our test set that we are going to use to predict and verify the model accuracy. Run this. All right, the prediction has started. This is completed now. Let's take a look at the data, and then we'll do a little bit more exploration once we quickly verify that everything is correct here. Now let's click on data management. Here is the machine learning prediction output. We click here, no-show prediction. Here is our prediction result. So this is the prediction column. 1, 0. 1 means it's a case of no-show, and 0 means a case of no-shows. Now, if you want to do some more exploration on this result, you click on interactive query. So we say select, and this was the original no-show, and this is our prediction. And as we know, this is used as a table, so we can simply say this. So this will So we see here that these are the original column no-show result, and this was the predictor result, and they're matching pretty okay. Same way, we can build multiple models and see what the accuracy level looks like. So what we will do, we'll create another model, and this time we are going to create random forest classifier, and version number. These are the feature fields, and dependent variable in this case is no-show. Maximum number of category, let's say we give duration 100. Same regularization parameter. Use the training set in the RF classifier. run this. Great, so this has completed in 57 seconds. Let's look at the model. So here is the model, and here's the accuracy level and all other evaluation summary. We'll use now this model to do the prediction. Now the steps are the same. You click on machine learning prediction, create new prediction, and let's call it no-show prediction using random forest. Columns are the same. Select the model. In this case, we'll select the random forest classifier. And here is my test set. Bring the test set in, connect, run, and let's wait until this finishes. Great, now this has completed. And let's look at the result, the prediction result using random forest. And everything looks good. Here is the prediction outcome with the probabilities. So we have seen two different models, artificial neural network and random forest. These two models have different level of accuracy that you can compare and see which model is the best, and you can use one of those models. Hope this video helps you with getting started with Momentum AI. In this video, we created two different models, neural network or deep learning based model and random forest. We use these models to predict no-shows for doctor's appointment. More training resources and videos are available at our website at acure.ai. If you haven't done so, please sign up for an account at mv.acure.ai. Thank you for watching this video.